we've learned about how to write chemical reaction. Before we are going to investigate the different type of chemical reactions, we have to know how compounds are reacting in aqueous solutions. So in this video, we are going to investigate the different types of compounds in aqueous solution. Okay, so we've learned that we have ionic compounds and molecular compounds. So let's see how each of these type of compounds react in water. Okay, so when you dissolve an ionic compound in water, it dissociates into individual ions and disperse among the water. For example, when you have NaCl, the table salts, when you dissolve it in water, it's not NaCl anymore. It's Na plus cations and Cl minus anions. It's just dispersed in the water, in the solvent, okay? And each of these ions are surrounded with the solvent molecules, which is water in aqueous solution. And they are called as hydrated ions because they're surrounded with water, okay? So here is our phase that I told you about it in the last video. It's aqueous. Now our ion is aqueous because it's solvated or hydrated ion. So we write AQ on that. So this is how we write it. So we have NaCl solid. It's in solid state. When you add water to it, it's now NaCl aqueous. Okay, so you write AQ in front of it. Okay, after the ion. And actually we write it like this, but basically it's just sodium cations aqueous and chlorine anion aqueous. Okay, that's basically how it is in the solution. This basically shows what we were talking about. So we know NaCl, and we talked about it, that ions are not like molecular compound. They are not simply one sodium with one chlorine. It's a group of ions just gathered together. You have Na, you have sodium chloride, sodium chlorine, and that makes a big structure. It's actually as big as you can basically see the cubes if you look at the salt. Okay, so when you have this ionic compound and you put it to the water, it dissociates into ions. Now each of these ions are surrounded with water. These ones are the water molecule. It's H2O. The oxygen, since it has more negative charge, slightly negative charge, these are some things that you will learn in the next more advanced chemistry classes. But oxygen in the water has more negative charge, so that is going to be absorbed on the cation. And hydrogen have slightly negative charge, so if you have positive charge, so when you have the anion that has negative charge, the hydrogen are going to be covering the surface of the anion. So that's what hydrated ions look like. So that leads to the concept of electrolytes. So aqueous solution of ionic compound can conduct electricity due to the mobile hydrated ions because they're free now. They're not in the solid state. They can move freely in the solution. They can conduct electricity. Electrolytes are substances that when they're dissolved in water, they can conduct electricity, and that's why that solution is conducting electricity. Ionic compounds, which are soluble, and we are going to talk more about what are soluble ions and what are not, are insolubles in next slides. So ionic compounds which are soluble and they are dissolved completely 100% into its ion, they dissociate into their ions, are strong electrolytes. Okay, so if a compound basically dissolved in aqueous solution 100% to its ions, that's a strong electrolyte, and the ionic compound are one of them. So how molecular compounds react in aqueous solution in water? So you know that molecular compound or have the like 1 unit of the molecule, right? So they do not dissociate like ionic compounds. They do not have this interaction between ions. They're just whole one unit of molecule. Okay, so when they dissolve, when we dissolve these compounds in the water, they just stays as the molecular unit in water. Okay, and they do not have any charge, so they cannot conduct electricity. Okay, so they are non-electrolytes. Okay, these are called non-electrolytes. So non-electrolytes dissolved as molecule. Acids are molecular compounds that ionize. Yes, I know it might be a little confusing, but that's still true. Acid is a molecular compound, and when we say ionize, they just gives off the H plus ion, and we will talk more about how acids and bases make ion in a solution in acid-base reactions. What you need to know now is that acids will ionize to and they will conduct electricity, so they are um, electrolytes. And the more strong the acid is, the more H plus, the more ion it will gives off to the solution. And as I said, we will talk more about how acid and bases react in water more in the next lecture slides. So strong acids ionize 100%, and that makes them a strong electrolyte. So to sum up the electrolytes, we have this table in the next slide. So the solution type, if we have a strong electrolyte, what type of solutions we have strong electrolytes? So if we have ionic compound that 100% ionize in the solution, that's a strong electrolyte. If we have as a salt, if we have an ionic compound which is a strong base, and we will talk about acid and base in the next sessions, but strong acid and base are strong electrolytes, and these are the example. Weak electrolytes are acid or bases that do not completely dissociate into the water. So weak acids and weak bases are weak electrolytes also. And molecular compounds, most of them do not ionize, and if they do not ionize, they do not conduct electricity, so they are non-electrolytes. So we talked about ionic compound and how they react in the solution. We said they dissociate into the ions, but as I mentioned, it depends if it's a soluble ion or insoluble ion. Soluble ionic compounds are the ionic compound that dissolve in water, and insoluble ionic compounds are the ones that does not dissolve in water. And to determine if they're soluble or not, we have to memorize the solubility rules. One thing that you have to remember, that even the insoluble ones always dissolve to some tiny extent, that you're going to learn more about these ones in the next chemistry classes. So this is the solubility rule, the common ionic compounds in water. Okay, in this table, the first one are the cations that are soluble, no exception, which means any ionic compound that has the cation that are listed in this table are all soluble in aqueous solutions. And these are alkali metals, the metals in the first group of the periodic table, and all ammonium salts, NH4 plus. Okay, these cations, if you see them in an ionic compound, they are definitely soluble, no exception. The next one are the anions that have no exceptions, and they are soluble in aqueous solutions. You can see it in this chart. And the next one are halides, and these three, and you have to remember that fluorine is not listed here. So halides are soluble except if they form a compound with these three. Otherwise, they are soluble. Also, sulfate ion, any compound that has sulfate ion in it is soluble, except if it makes an ion with these 6 cations. Okay, so in order to make it easy for the soluble compounds, let's see the next slide. So if you remember cash NGA, what is that? Cash NGA. So I write it this way: cash and Gia. Okay, so C is for chlorates. All chlorates are soluble. A is for acetate and ammonium salts. All acetate and ammonium salts are soluble. Sulfates are soluble except CBS, the channel. And what is CBS? It's calcium, Ba, and Sr, happy. And what is happy? Hg, 2 plus, Ag plus, and Pb, 2 plus. And I write Py to just make it happy, to make you happy, to make it easier to memorize. Next one, halides. And you can see it in the table, those three halogens are soluble except happy. And I write this Py, so Hg, 2 plus, Ag plus, and Pb plus, 2 plus. So except these three halides are soluble. All nitrate are soluble. And GIA is group 1A salt, which are lithium, potassium, sodium. So if you see any ionic compound with a cation with the first group, they are all soluble. So this all soluble. So this basically summarizes the table that we saw in the previous slides. It almost covers everything, but still it just helps to memorize, but you have to check with the table, see if you have anything that misses in this abbreviation. In this chart we have ions that are insoluble with some exceptions. So if you see these anions, it means the compound is insoluble except, well, of course, alkali metals, you know that they are all soluble without any exception. So if these anions are with the alkali metals, then it means that they're soluble. Also, the ammonium salt. The other anion, which is insoluble in most cases, is hydroxide ion. So if it forms a compound, ionic compound with hydroxide, it's insoluble except if it's with the first group metals or with these three. The last one is slightly soluble, but still. So these are the compounds that are not soluble except if you have it with these ions. Okay, so now let's have some practice. So which of the following ions leads to ionic compound which are always soluble? No exception. So if you remember from the chart that we said, or with the acronym cash and Gia, so the last one was group A metals and lithium was group A metal, and there was no exception for that. So this one should make a compound which is soluble, no exception. What about this one? Is it soluble or not? Well, if you remember, sulfates are in our cash and Gia, so S was for sulfate. And sulfate was soluble except for CBS, calcium, barium, strontium, and with happy, HAP, happy. So Hg, Ag, and Pb. And Ag was one of the exceptions, so it's Ag and sulfate, so this is insoluble. Next one, so is lithium sulfide soluble or insoluble? So lithium is in group 1, and group 1 ionic compounds were all soluble, no exceptions. Sulfides were insoluble, but there was an exception with group 1. So in either case, if you in either way you want to go with it, it's not it's soluble. So it's A. All group A compounds are soluble. PB nitrate. So nitrates are all soluble, no exception. So this one should be soluble. And the last one, AgCl. Is it soluble or not? So chlorine, halide, is in our Cashangia in halide. And you know that they're soluble except with happy. So it's Hg, Ag, and Pb. This one is with Ag, so it's not soluble. It's insoluble. Okay, I hope you had enough practice. You can have more practice, and by the end of the chapter, practice problem, and just go through the chart, go through the table to see what compounds are soluble and what are not.